All right, so in this video, we will be looking at question 1 of the CSEC Chemistry June 2021 class paper. All right, so the paper started out with the topic of electrolysis. So it says a student conducted an experiment to determine the products formed from the electrolysis of aqueous copper sulfate using inert electrodes. And figure 1 shows a simplified diagram of the apparatus used. So this is the diagram that was on the exam paper. So typically you have your power source. In this case, it's a battery. And as usual, we label the positive and the negative electrodes, all right, or the terminal in this case, all right? So we know that the positive electrode, which is the anode, is on this side, and the negative electrode, which is, sorry, which, right, so this would be our anode. Over here we have the cathode, and the electrolyte, of course, is a solution of copper sulfate. So the question went on by giving us the procedure. So it says a current was passed through the electrolyte and the starting time was recorded at 10-minute intervals for an hour. The volume of oxygen evolved and the mass of copper deposited is measured. At the end of the reaction, the total mass of copper was 4.85 grams. The volume of oxygen evolved is shown in table 1. So they gave us the table with the time and the volume of oxygen that was produced. So the first question asks us to define electrolysis, which is simply the decomposition or the breakdown of the electrolyte when an electric current passes through it. And then they had asked us to give one inert electrode that could be used. So you could use, typically we use graphite, but platinum is also an inert electrode. Okay, so that was part B. Hold on just a second. So this should have been A1. All right, so it was A1 that asked us to define electrolysis, and B2 to, uh, to state an inert electrode. So you could state either graphite or platinum. B1 now is asking us to plot a graph of volume of oxygen versus time. So we have volume here from 1 to 9, and on the x-axis, it's time in minutes. The units or the scale, it was already provided for you. All right, so I'm just going to put on the values. It won't be as accurate, but it can work. All right, so the first value, we should have one for 10. So the first value for the time is 10, and the volume is 2.4. So we have 10. 2.4 is approximately midway between 2 and 3. So we're going to put a point right there. And then the second one is 20 to 3.6. So we find 20, and the x, 3.6 would be approximately midway between 3 and 4. Right, so you go across to 20. So probably about here, right there, thereabout. All right, and then 30, 4.8. So it's a bit closer to 5. Again, you would have your graph paper to do it more accurately. And then 40 to 6. So we have 6 going across to 40. And then 50, 7.2. And then 60, 8.4. So you plot the graph and draw a best fit line. So I'm just going to draw a straight line through the points. Use a block. All right. So there we have it. That's our line of best fit. So your graph should look something like this. When you plot it, you should get a straight line. So that was for part B, number 1. B2 now is asking us to, let me just type it so it's there. Okay, so it says use the graph to determine the time it took for 5.50 cm cube of oxygen gas to be liberated. So if you want to do this, you are going to find, so remember, y-axis, that's the volume of oxygen. So you would estimate where 5.5 is, and you're going to draw a line from there. So I'm going to look at the 5.5. Just a second. So you locate 5.5. Draw a line from there to your to the line of best fit. Once wherever it touches the line of best fit, you're going to draw a vertical line to the x-axis. Wherever it touches the x-axis, that's the volume. So it's about midway between, well, not the, oh, it has said use the graph to determine the time, right? So it's between 30 and 40 minutes, so about midway. So we could say it's about 35 minutes. So first, you find 5.5 cm cube, draw the line, go across to where you extrapolate it, or to where you draw the line of best fit, and then you just bring it down to the x-axis and you read it off. So our answer is 35 cm cube. So we're going to move on to part C. All right, so part C, it asks us to identify the ions present in the electrolyte. So if it is aqueous copper sulfate, that means it is the solid copper sulfate is dissolved in water. So you would have the copper ion from copper sulfate as well as the sulfate ion. So you have the copper 2 plus and the sulfate ion. And then you have the hydrogen ion and the hydroxide ion from the water. And then for part 2 now, it asks us, so let me label this. So this was P and this was Q. So it asks us to label the electrodes P and Q. So we know the positive, that is the anode, and the negative, that is the cathode. Then it asks us to identify one ion that will drift towards the anode. So we know the anode is positive, so any negative ion in solution will drift towards the anode. So you could put the hydroxide ion as your answer, or the sulfate ion. The actual formula for sulfate, it's let me try and draw it. It is SO4 2 minus SO4 2 minus. All right, so that's the sulfate ion. For part 4, it asks us to write an ionic equation for the reaction taking place at the cathode. So as we said, at the cathode, the positive ions would migrate to the cathode. But remember, in this one, the copper will take part because copper is below hydrogen in the electrochemical series. So you would have the positive copper ion, Cu2 plus. And remember, at the cathode, reduction occurs. So the positive ion would migrate to the electrode and gain whatever the charge is on the positive ion, that's the amount of electron it will gain. So Cu2 plus, it will gain 2 electrons. To give the atom of copper. Right, so we put an S for solid and AQ for aqueous. That's not why, that's a Q. Right, AQ. So it's Cu2 plus 2 electrons to give copper sulfate. So that was part 4. Part D is calculations. All right, so I'm going to clear this and then we're going to work part D. Right, so this is part D. You can pause the video and work it if you want. So it says calculate the quantity of electricity that passed through the copper sulfate solution when 3.5 amperes of current flowed for 1 hour. And they provided you with the formula to calculate the quantity of electricity, which is the current multiplied by the time. The time must be in seconds. So the first thing we must do is convert the time into seconds. All right, so remember 1 hour, that is 60 minutes. All right. So to convert the 60 minutes into seconds, we have to times it by 60. 60 seconds is a minute, so 60 times 60, 3,600 seconds. And then we know that I, which is the current, that's 3.5 amperes. So 3,600 times 3.5, we get 12,600. And the unit for the quantity of electricity, that's coulomb, so we put C. The next part now, it says calculate the number of moles of copper deposited. All right, so to do electrolysis, there are more than one ways to actually work this out. All right, but what I do to work the moles, all right, so get the mole, I will divide Q, so whatever the quantity of charge is, that's Q, and I divide it by what I call Q1. All right. So if you want the mole, it's Q over Q1. Q is the quantity of charge. Now to get Q1, I am going to write the balanced equation, which we already did. Right. So if you remember, all right, let me just do it again. All right. So to find Q1, Any amount of electrons that are used in the half equation, we are going to multiply it by 96,500 coulombs. So when we're looking at electrolysis, and we know that the electrons flow from the anode to the cathode, right? The electrons, each electron is carrying a charge of 96,500 coulomb, all right? And if you look at this equation, it takes 2 electrons to give you 1 mole of copper, right? And remember, each of these electrons are carrying a quantity of charge. Sorry, each of these electrons are carrying 96,500 coulomb. So what we're doing, right? If you use 2 electrons, you are carrying twice the amount as 96,500. Good. So that is the amount of charge that is used to form 1 mole of copper based on this balanced half equation. So if it takes that amount of electron to form, sorry, if it takes that amount of charge to form 1 mole of copper, how many moles will 12,600 coulombs provide? All right. When it comes down to it, however you work it out, when it comes down to it, you will end up dividing this number, right, by whatever number you get when you multiply the amount of electrons by 96,500, which is 193,000. So let's just work that out. All right, so I multiply the 2 by 96,500. So it takes 193,000 coulombs to produce 1 mole of copper. So by dividing the quantity of charge we calculated from the question, which was 12,600, and we divide it by the amount based on the half equation, we will get the number of moles. All right, so whenever you get this question again, you simply divide the quantity of charge from the question, right? So when you say Q equal I times T, right, that Q, we are going to divide it by Q1. And again, to get Q1, all you do, look how many electrons are used in the half equation. And you don't even have to look at the half equation. Whatever the charge is on the ion, say if it is 2 plus, you multiply 96,500 by 2. If it was a 3 plus, 2 minus, whatever the charge, that's the number you will multiply 96,500 coulombs by, right? And again, there's more than one way of doing this, but you will end up dividing this number that you calculate here by this one, all right? So that's how we got the moles here. In part 3, it asks us to find the mass. And we know that mass is equal to mole times molar mass. So that would be equal to 0.065 times 64. We'll get 4.16 gram. All right, that was part B. Well, we have a next part, so let me just write it down. All right, so continuing back from part 4, so it had said, give a reason for the difference in mass of copper calculated and that measured by the student. So based on our calculation, we should get 4.16 gram, but the student obtained 4.85 gram. Remember, the longer the experiment is allowed to continue, the more mass of copper that is being deposited. So if the student got 4.85 gram, it means that they could have allowed the experiment to go beyond the 60 minute as they should have done. All right, so the extended time is a possibility. Then it says for part E, state the color change that would have taken place in the electrolyte after a few hours. So we know that copper, the Cu2 plus ions is the reason why the copper sulfate solution is blue. So if you look here, so Cu2 plus, that is the reason why copper sulfate is blue. If these ions are converted to the copper atom, then the blue color will be lost. So as a result, the solution, it would change from blue to colorless. And then the final question, part F, says state how the electrodes in figure 1 can be modified to obtain pure copper from impure copper. So in the purification of copper, we put the impure copper metal at the anode and the pure copper metal at the cathode. So all they wanted you to do was tell what you would put at the anode and what you would put at the cathode. And this question had a total of 25 marks. All right, so part F, let me see. Part F. F was worth 2 marks. Part E, 1 mark. Then to do part 4, that was 1 mark as well. So 1 mark. The calculation here, to calculate the mass, that was 1 mark. To calculate the moles, here, it was 2 marks. All right, so you can use the half equation when you're showing that. And to calculate the quantity of current, that was 2 marks. All right, if you have any question, you can leave it in the comment section. So that is it for this video.